So this 8421 code will be enough to represent up to the value called 15. But what my number is greater than 15, then you have to multiply this and you have to get. Okay. So I told you already, any number, that can be any number, can be converted into binary with the help of this 8421 format. Wherever we have 1, we have to consider that value or that position to be added in order to get any of the decimal number. Hello everybody, welcome back to the second session on chapter 3, that is data representation. I am Rohini TS, lecturer, Department of Computer Science, Vidhyaashram Pre-University College, Mysuru. So in the previous session of this chapter, we learned about why data representation is important. For that, we are going to use a number system, right? So number system is a methodology of representing the digits, that is in a well-formed symbols. So that symbols are nothing but digits. Then what are the types of number system we have? That is what? Non-positional number system, and then we have positional number system, right? So in number system we have two types, non-positional number system and we have positional number system. So in non-positional number system, Roman number is an example for this non-positional number system. Then in positional number system, again it has been classified into 4 types. That is what? Decimal number system, and we have binary number system and octal number system, and we have hexadecimal number system, right? So in each type of a number system, you have to remember its base or a radix value and its power. That means what? How many total number of digits it has. So in decimal, it has 10. The base is 10 and it consists of 0 to 9. In binary, the base is 2 and it has either 0 or 1. In octal, its base is 8 and the numbers are between 0 to 7. In hexadecimal, the base is 16 and the number we have 0 to 9. Along with that, we have A to F. So A represents 10 and F represents 15. So this is what we have discussed in the previous class, and we will get to know that how we are going to represent each number with a particular type of number system. So in today's session, we are going to learn about the conversions. So anyway, computer understands only zeros and ones. Any number system it can be, it must be converted into binary number system. Then only computer will going to understand it. So that in today's session, we are going to learn about the number system conversion from one type of number system to another number system. But in today's session, we are going to learn about the conversion of decimal to binary and decimal fraction to binary. Okay. So these are my today's session's content. So let me get into the session. So before that, you have to understand number system table. So we have 4 types, right? In positional number system, we have 4 types. We have decimal, binary, octal and hexadecimal. Already we know the numbers, that is total number of digits present in each type of number system. So if it is decimal, then total is 10, that is 0 to 9. Base is what? It's 10 always. And in binary, we have only 2 numbers, that is 0 or 1, and in octal 0 to 7, and hexadecimal 0 to 9 and A to F. Then how we are going to represent each number type numbers in each type of number system which is related to binary. So we'll see now. So here we have a decimal, binary, octal and hexadecimal. So what is the base of this decimal? That is 10, and base of binary is 2, base of octal is 8, base of hexadecimal is 16. Then what is this base that is decimal number system consist of? It has 0 to 9, right? It has 0 to 9, and in base 2 we have what? 0 or 1. Any number it can be. It has to be represented with zeros or ones. So in base 8, that is octal number system, there we have 0 to 9 combination. It can be any number. Okay. Then here it has 16 digits or a 16 numbers, that is between 0 to 9 and A to F. So here 0, 0, 0, 0. How we will get to know that any number type of system, it can be decimal, octal or hexadecimal, has to be converted into binary. Why? Because computer understand only zeros and ones. So now how we are going to do these conversions, how to remember these values, let me show you. So for that you have to follow 8421 method or 8421 code or 8421 methodology you can call. Okay. So let me take one value. So 0, 1, 2, 3, 4, 5, 6, 7. So let me show you how we are going to represent any number with a binary number system. Okay, it has to follow 8421 code or a methodology. So now you tell me, by adding which number I can get 0 here. I can get 0 by adding which number. So before that, understand, so this 1 is nothing but 2 power 0, this is 2 power 1, 2 power 2, then 2 power 3. So if your number is larger, so then if you add all these numbers, how much you will going to get? 8 plus 4, 12, 12 plus 4, 14, 14 plus 1, 15. So this 8421 code will be enough to represent up to the value called 15. But what my number is greater than 15, then you have to multiply this and you have to get. Okay. So its next will be raised to 16 and next will be 32. So it will be goes on like this up to 256, that you can say. Okay, so 2 power 3, 2 power 4 and it will become 2 power 5. So now, as of now, you just consider only 8421 format. How we are going to represent 0 in this 8421 format or in the binary? So understand one thing, by adding which number I can get this 0, no need to add any number. So any number if I add, then we won't get the 0. So that how we are going to represent 0 then? 0, 0, 0, 0. Okay, then how can I get this 1? By making use of this 8421. So I have 1 here. So where is 1? There I am going to put 1 and remaining value become 0, 0, 0, 0. So 0, 0, 0, 1. How we are going to get 2? So here I have 2. I am going to put 1 in that place and remaining value become 0. For 3, which number should I add? I have to add 2 and 1. Then only I am going to get 3. Okay. So yavaga illi 3 barutte namge when I add 2 and 1. So that I have to put 1 and 1 in the position of 2 and 1. Then only I will get able to get this 3. So the remaining value will become 0 and 0. How we are going to get 4? So I can take only 4. No need to take any other number to get 4. So that I am going to put 1 in the place of 4. The remaining value will become 0. Then how we are going to get 5? I am going to add 4 and 1. If I add 4 and 2, it becomes 6. If I add 4 and 1, then only I am going to get 5. So that in the place of 4 and in the place of 1, I am going to put 1 and remaining 2 value become 0 and 0. For 6, 4 plus 2 will become 6, right? So 4 and 2, I am going to put 1, remaining 2 value become 0. For 7, 4, 2, 1. 4 plus 2 plus 1 becomes 7. So that 1, 1, 1 and this become 0. Okay. It can be any number. It has to be represented with the help of binary code. So for that you have to follow 8421 format. If the number is greater than 15, for example, if it is 23, let me consider 23. Is 8421 is enough to represent this 23? No. I have to take next digit. Next higher value is 16. Let me show you. 16, 8, 4, 2, 1. How can I get this 23 now? By adding which number I can get? I can add 16 and I can add 4. Now it becomes what? 20. 23 I want to take. So 22 and I am going to add 1 again. It becomes 23. The remaining 2 value remaining this 8 become 0. So it can be any number. If you want to represent it, go with this 8421 format. That is what I have shown in this table. Okay, don't need to mug up anything. You have to take 8421 format, then analyze the number, then convert it into binary values. So here you can see the values. So here it is left to you whether you are going to take 0 in the place of this 8 and 4. If it is not necessary, then no need to represent it. So base 10, base 2, base 8 and base 16. So here you can see that. So in hexadecimal we have up to A, B, C, D and up to F we have. F is nothing but what? 15. How we are going to 15? 8, 4, 2, 1. So 8 plus 4, 12, 12 plus 2, 14, 14 plus 1, 15. I am going to put all as 1. Why? Because I have to add all the values in order to get 15. That will be equivalent to F in my hexadecimal number system. This is what the representation or a number system table. Okay. So just remember the base value and just remember how we are going to convert a number to 8421 format. That will be enough. So now we'll see the conversion from decimal to binary. So now you just recall what is decimal number system consist of, what is binary number system consist of. So decimal number system, there we have the base or radix is 10. And what are the number it includes? It includes 0 to 9, right? And now I have a binary number system and its base or radix is 2 and it can be either 0 or 1. So this is the basic thing you have to understand decimal to binary. How we are going to do the conversion from decimal to binary? I have any number, okay? Let me consider this as 73 and base is what? 10. I have to convert it into its binary. So decimal to binary. So number is 73 which is of the base 10. I have to convert this into binary. Okay, I don't know what value I am going to get, but it base or radix value must be 2. That is what I am trying to converting from this decimal number system to binary. So we'll see the step. This is very important question for 3 marks. Okay. So what are the steps we have to follow when we are converting decimal number to binary? We'll see now. So in step 1, divide the given decimal number by 2. What is the first step? We have to divide any given decimal number by 2. Okay. So how we are going to do the calculation, that is how we are going to do the division normally. If it is 73, let me take 73. How we are going to do? So like this you are going to do. But when we are converting or when we are working with a number system, don't take the format like this. Instead of this, you have to take like this. So 73 which will be divided by 2. Okay. Don't use this format, use this format for division. So this is regarding what? First step. First we have to divide the given number, that is given decimal number, by 2. Okay. So I am trying to divide. We'll see the step 2. Take the remainder and record it on the right side. So understand one thing, this is quotient. Okay. So I have to divide this value by the 2. Then whatever the remainder I am going to get should be on the right side. We'll divide now. So 2, 7. How I am going to divide this 73 by 2? So 2, 3 is a 6. So 2, 3 is a 6. 7 minus 6 will be, remainder is 1. I am going to take this here. Then it becomes 13 now. So 2, 6 are 12. Okay. What is the remainder? 13 minus 12. The remainder is 1. Okay. I have divided a given decimal number by 2 and I have recorded its remainder in the right side. Okay. Next, step 3, repeat the step 1 and step 2 until the decimal number cannot be divided further. When the quotient value becomes 0, then we cannot divide that number. Okay. So up to that we have to do the calculation. That means what? We have to divide the step 1 and step 2. Step 1 is divide the decimal number by 2. Then in step 2 we have to record the remainder. I will show you here. So now again 2 ones are 2. 3 minus 2 will become 1. It becomes 16. 2 8s are 16. Is there any remainder? 18 2s are 36. No remainder. Then put 0. Then 2 9s are 18, remainder will be 0, and 2 4s are 8, the remainder will be 1, 4 2s are 8. So 9 minus 8 will be remainder 1. Then 2 2s are 4, remainder will be 0, then 2 1s are 1, the remainder will be 0. Okay. So can I divide this 1 by 2? We cannot divide. So when we have to stop the division, when we cannot divide the quotient value, then we have to stop. Then how can I write it? So 2 zeros are 0. The remainder will be this one. So now this become my MSB and this become my LSB. That is what I have discussed in the previous class. MSB is nothing but leftmost digit, and LSB is the rightmost digit that has lower weight, and MSB has more weight. So that is most significant bit, and this is least significant bit. Then how we are going to write an answer from MSB to LSB? Okay, so what is the equivalent of 73 now then? 73 base was 10 and it has been converted into decimal from here to here, from MSB to LSB you have to write. So tell me the value here, 1 0 0 1 0 0 1. So what is the base of binary? That is 2. Okay, we have converted a number called 73 which is of the decimal to binary by making use of all these steps. So whatever the given value is there, try to divide that by 2. If there is any remainder, it will going to be surely either 0 or 1. Okay, so mark that remainder, then divide all the value one by one. When you have to stop the division, when the value or a quotient which cannot be divided further by 2, then you have to stop its division. So then you have to mark its MSB and LSB. MSB is the highest value or higher weight, and LSB will be the least value. So the leftmost digit will be considered as MSB and rightmost digit will be considered as LSB. Okay, so further you are going to get a value which is from MSB to LSB, and its base must be 2. Why? Because we are converting from decimal to binary. So we'll see the example for conversion of decimal number system to binary. So here I have a decimal number called 87. So 87 base 10, that represent what? We have a decimal number. What was the first step? I have to divide a decimal number system by 2. Okay, so let me divide this by 2. So 2 4s are 8 and then 2 3s are 6. The remainder will be 1. So 43 into 2 become 86. 87 minus 86 will be 1. Next 2 2s are 4 and then 2 1s are 1. Remainder will be 1. 21 into 2 will become 42. 43 minus 42 will be 1. Again 2 10s are 20. The remainder will be 1. 2 5s are 10. Remainder will be 0. And 2 2s are 4, remainder will be 1. Again 2 1s are 2, remainder will be 0. Can we divide this 1 by 2? No. So that 2 zeros are 0, the remainder will be this one. So this become my MSB now and this become my LSB. How we are going to write the value? That must be from MSB to LSB. So now this 87 base 10 which is equivalent to, let me write it as 10. Okay, 87 base 10, that is equivalent to the binary value 1 0 1 0 1 1 1 1 0 1 0, then 111. What is the base value? That is 2. We have converted a decimal number from, that is we have converted a decimal number to binary equivalent value. That is what I have shown here. So 1010 111 which is the base is 2. Don't forget to write this base. Okay, so this is the MSB, that is most significant bit. Whatever the rightmost value is there in the output, that is least significant bit. So MSB to LSB we are going to write. This is how the conversion of decimal to binary. So let me take one more example. 283. Okay, so this is my decimal number. I have to convert it into binary. So 283 divided by 2. 2 1s are 2, 2 4s are 8 and 2 1s are 2. Remainder will be 1. Then 2 7s are 14 and this becomes 0, this become 1. That means 70 into 2 will be 140. 141 minus 140, the remainder will be 1. Then 2 3s are 6. Then this become 10, 2 5s are 10, remainder will be 0. Then 2 1s are 1, 15, 2 7s are 14 and this become 1. Okay, 17 into 2 will be 34, 35 minus 34 will be 1. Then 2 8s are 16, the remainder will be 1. 2 4s are 8, the remainder will be 0. 2 2s are 4, the remainder will be 0. Then 2 ones are 2, the remainder will be 0. Again we cannot divide 1 by 2, so make it as 2 zeros are 0, the remainder will be 1. This is my MSB and this is our LSB. So 283 base 10, that is equivalent to, what is the value we have? 1 0 0 1 0 0 0 double 1, and we have 0 double 1 0 double 1. Okay, what is the base? That is 2. If you convert this into 8421 format, surely you are going to get 283. So let me show you that one. 8421, and here it becomes 16, 32, 64 and 128, and this become 256. So wherever we have 1, we'll add now. Okay. So for 250, this is just for your cross verification. Don't use this method in your examination. 256 plus 16 plus 8 plus 2 plus 1. So 3, 8 plus 3, 11, 11 plus 16, 727. So 256 plus 27, 6, 6, 3, carry 1, 5 plus 1, 6, 6 plus 2, 8, and this we have what? 253. Okay, so I told you already, any number, that can be any number, can be converted into binary with the help of this 8421 format. Wherever we have 1, we have to consider that value or that position to be added in order to get any of the decimal number. Okay, this is just for your cross verification, whether we got the proper answer or not while dividing, did we miss anything. So just for the cross verification, go with this method. Okay, this is how the conversion of decimal to binary will going to happen. So now we'll see the next method, that is converting of a decimal fraction number to binary. So now we have divided a complete, that is whole number of decimal to binary. But what if I have decimal fraction? We'll see now. So here we are converting decimal fraction number to binary number system. What are the steps are we supposed to follow in order to get the decimal fraction to binary? So in step 1, multiply the given decimal fraction number by 2. So in whole decimal number we are going to divide, but once we have a decimal fraction, we have to multiply, not to divide. We have to multiply the given fraction value of the decimal number with 2. Okay, then in step 2 what we are going to do? Note the carry and the product. So we are going to multiply, we are going to get product, and we have to follow the carry. Carry is nothing but what? It's remainder itself. Then repeat the step 1 and step 2 until the decimal number cannot be divided further. So when the decimal number become 0, we cannot divide it further. At the time we have to stop the conversion. So at the time we have to stop the multiplication. Okay. So in step 4, the first carry will be the MSB. So in the decimal conversion to binary, what we have done? We have MSB and we have LSB. So MSB is the most significant bit, that is leftmost value. So LSB is the least significant bit, which is at the rightmost value. So that here also we have to first, we are going to multiply and we are going to get the product as well as the carry, right? So in carry we are going to get either 1 or 0. So that will be the remainder. So we are going to get, what is the first carry that we are going to get? That will be the MSB, that is most significant bit, and the last carry will be considered as what? Least significant bit. Then the equivalent binary fraction number is written from MSB to LSB. Wherever you go, whether it is what? Right side, from the right to left, or from the left to right, whatever it could be, first you have to write its MSB, at last end up with LSB. Okay. We'll see the example of conversion of decimal fraction to binary. Okay, so here we are converting the decimal number called 0.3125. So 0.3125, which is of the base 10, to be converted into number that I don't know, I have to do now. Okay, so it will going to lead us to get binary number. So we already know the steps that what we are supposed to do. In step 1 we are going to multiply the given number by 2, and whatever we are going to get, we have to mark its carry and product value. Okay, so let me start with this 0.3125. okay, into 2. So if I multiply 0.3125, then what we are going to get, that is 0.625. So if I multiply 0.3125 with 2, then we are going to get 0.625. So here this is just a product. So what and all we have to follow? We have to find the carry along with the product. Okay, so carry will be this one, whatever is there before the decimal point. So here you are able to see, no, 0.625. This is nothing but decimal point. So whatever is there left side of this decimal point, that we are going to call that as a carry. Okay, so if I have to mark this carry and product, so I am going to make that carry as 0 and product will be 0.625. So now I am going to just discard this. So I am going to just discard what I have. I have 0.625. 0.625 is same as 0.625, right? So 0.625 into 2. If I multiply 0.625 by 2, then what we are going to get? We are going to get 1.25. Okay, then which is the carry now? That is this one. Okay, that what we are going to mark here. The carry is 1. Then what we are left out with? We are left out with 0.25. I can write that like as 0.25 into 2. So 0.25 into 2, what will be the product? That is 0.50. Is it? So 0.25 into 2 will be 0.50. Then this 0 will be marked as carry here and 0.50 will become my new product. So that 0.50 into 2. What we are going to get? 0.50 into 2, we are going to get 1.00, right? So I am going to mark this one as the carry. Then what we are left out with? We are left out with 0.00. So 0.00 is nothing but 0.00. If I multiply any number with 0 and 0, we are going to end up with 0. This is what the position where we have to stop its multiplication. Okay. So in first step, we are going to multiply the given decimal fraction by 2 and we are going to find its product and we are going to mark its carry. Either it can be 0 or 1. So which is the first carry that we are going to get? Will be the MSB, that is most significant bit. And which is the last carry that we are going to get? That will be the LSB, that is least significant bit. So here you are going to write an answer from this way. Why? Because MSB to LSB we have to write. Then this 0.3125 is equal to, this fraction, decimal fraction is equal to what? 0101, which is of the binary value base 2. Okay, this is how we are going to find the decimal fraction to binary number system. So here you can see that what was the number? That is 0.3125, which is of the base 10 to be converted into binary value, right? So here 0.3125. This 0.3125 is my fractional part and this is a whole number. If I divide this 0 by 2, then I am end up with 0 itself. So that 0 I have to take point. What was the answer that I got? That is 0101. So that is should be written in the place after this decimal point, that is 0101, which is of the base 2. Okay, so this is equivalent to this value. So that is what I have shown here. 0.3125 will be multiplied by 2, then we will get 0.6250. Again that will be multiplied by 2, right? Then what we will get? 1.2500. So this 1 will be the carry, the 0 will be the carry, and again this 0 will be carry. This is a carry. The first carry that we will get will going to be called that as MSB. The last carry that we are going to get will be called as LSB, that is least significant bit. So when we have to stop the conversion, here we have to stop. How can I get to know that? Because here the fraction part is 0. If I multiply that 0 again and again I will be end up with 0 itself. So that at that part you have to stop. Then what is the equivalent value of this 0.3125? to the binary, that is 0.0101, which is of the base 2. So whatever the point that we are going to write in the binary value, that is binary point. If I am writing the point here, this become decimal point because this has a base 10. If I am writing or if I am putting this period or a point here of the binary, then this become binary point. Okay, this become decimal point. If I am going to use this period or a point in the octal, then that become what? Octal point. Okay, this is how the calculation part will going to takes place. So now we'll see one more example to convert a decimal fraction number to binary number system. Okay, so here what is the question? 152.067187 which is of the base 10 to be converted into binary number system. This is my question here. Okay, so in this example we have both the parts, that is what we have whole numbers and also we have fractional part. So 152 is the whole number and 0.067187 is the fractional part. Okay, so whatever is there in the whole number should be converted as we did in the decimal to binary. How I did decimal to binary? There we have to divide a given whole number or a decimal number by 2. Then we have to mark its remainder. Okay, so from MSB to LSB we are going to get its value. In the same way we have to perform that operation for this 152, and whatever is there in the fractional part called 0.067, for that number we have to multiply it by 2. Okay, then we have to find the product and carry. We have to mark carry and its product. We'll see now. First let me consider this 152. It has to be divided by 2. Okay, so 2 7s are 14, this become 12, 2 6 are 12, the remainder will be 0, and 2 3s are 6, this becomes 6, 2 8s are 16, the remainder will be 0, again 2 1s are 1, it becomes 18, 2 9s are 18, remainder will be 0. So now 2 9s are 18, the remainder will be 1, and 2 4s are 8, the remainder will be 1, 2 2s are 4, remainder will be 0, and 2 1s are 2, the remainder will be 0. We cannot divide this 1 by 2, so that it become 2 zeros are 0, the remainder will be 1. What is this? This is our MSB and this is LSB, right? So from here to here we have to write. Then what is the equivalent value of this 152 now then? That is 1 0 0 1 1 0 0 0. Okay, so this is regarding what? Whole number. Now we have to go with fractional part. So in fractional part we have a value called 0.067187 that has to be multiplied with this 2. Okay, if I multiply this 0.671875 into 2, then we will get 1.343750. Okay, so whatever is there before this point, that will be considered as what? That will be considered as my carry. This is my product. Now it becomes what? 0.343750. That will be multiplied by 2. So again we will get 0.687500. So I have to mark the product and I have to take this carry. Now this become what? 0. So now I am going to multiply this 0.687500 with 2. Then we will get 1.375000. Okay, so this one become what? My carry, and this will be my new product, that is 0.375000 will be multiplied by 2. Then what we will going to get? 0.75000. Okay, so this 0 become carry now, and here 0.7500 will be multiplied with 2. Then we will get 1.50000. Okay, so this become what? New carry, and again it become 0.5000 will be multiplied by 2. Then we will get 1.0000 like this. So this will be my new carry. So now it becomes all the zeros. So if I multiply this all the zeros with 2, we will end up with 0 itself. So that at this point I have to stop the conversion. So this will be my MSB and this will be my LSB. From where to where we have to write a solution? That is from MSB to LSB. Then what is the equivalent value of this 0.671875? That is equivalent to 1, 0. This value I am writing 101, which is of the 101011, which is of the base 2. So together what we can write? That is for 152.067187, which is of the base 10, it is equal to, what is the equivalent value of 152? Let me write 100 and 110000. For this one we have 101011, which is of the base 2. Okay, so this is how the conversion of decimal fraction to binary will going to happen. So it's all about today's session. In our today's session, we learned how we are going to convert a decimal number to binary. Along with that, we are going to done the decimal fraction to binary. So in our next session, we are going to learn with the number system conversion itself. There we are going to learn about conversion of binary to decimal and octal to decimal, decimal to octal. So that and all we are going to learn. I hope you all understood with today's session. Let me meet you in the next session with the continuation of this chapter itself. Until that, keep learning, keep on growing. Thank you very much.